Hello everyone, welcome back to codingscientist.com. You are watching Hacking Raspberry Pi 0 to Hero series. Alright guys, so in the last couple of lessons, I hope you enjoyed plugging in multiple sensors into the sensor expansion board that is specifically for quick prototyping and stuff like that. In case if you want to productize your idea and quickly want to prototype by avoiding cluttering wires using breadboard and stuff like that, so that is the best way, right? Now from this lesson onwards, we will start building some electronics projects using breadboard, cluttering wires and LEDs, resistors, transistors, capacitors and stuff. The reason being, though it is little cluttery and cumbersome, but this gives you a very good idea on the basics of electronics and the GPIO pins. Most important thing guys, the GPIO pins, you need to understand how it works, especially the voltage and the resistance and stuff like that. So let's start from basics. So we are going to plug in a simple LED with a 220k resistor. Now what is a resistor? I'm not going to explain each and everything because these stuffs are available in Google. You can just type what is a resistor. It's got a color code and certain formulas to calculate and kind of thing. Or in case if you want to learn the basics, I have already built a couple of lessons before. It's called Top Tech Girls. A couple of my students built videos on different components of electronics. So you can take a look at that and you will get an idea about electronic components and kind of thing. However, here we are going to directly plug the components. I'm going to show the connectivity, the circuit drawing and write some program and make it work. So in order to get started, so this is the drawing you are going to build. It's a simple LED, directly connected to 220k resistor, and one of the LED leg, that is the positive pin, is connected to 3.3 volt, and the other end of the resistor is connecting to your ground pin, which is 0 volt, of course, which is called negative pin as well. So if you this particular circuit is going to make an LED light up by simply wiring it to 3.3 volt supply and negative 0 volt. So guys, don't forget the resistor. This circuit might work without the resistor as well, but this is to safeguard fluctuation in the electric signal. So this will protect your Raspberry Pi board. So you need to have one red LED or green LED or blue LED, whichever LED color you want, and then one 220k or 270 ohms resistor and few jumper wires and breadboard. Now as per this drawing, we have connected the positive leg of the LED to physical pin 1. Okay, so which is physical pin 1? One of my previous lessons, take a look at the drawing chart, right? I also showed you, I asked you to take a printout and keep it ready on your desktop, or you can also look at the pin by typing the command on the terminal. The previous lesson you learnt about it. So go ahead and pick up the pin number, physical pin number 1, which is basically a 3.3 volt pin, and then a negative leg of the LED to the first leg of 220 ohms or 270k resistor, whichever you want to use, and the second leg of the resistor is connected to the physical pin number 6 of Raspberry Pi. Now the same can be achieved physically by creating a positive and a negative rail on the breadboard, but let's take a look at it how it works. So let me show my circuit, how I put it together. You can just take a look at it here. So here I connected one leg of the LED, that is the positive terminal. The long leg goes to 3.3 volt, that is the first physical pin, of Raspberry Pi. This is the first pin, the other end, the inside end. Now one thing you might notice, I am still using the expansion board. That's because you don't have to keep removing the board again and again, because we have all the 40 GPIO pins exposed on top of the expansion board itself, so which is pretty good, right? And then the other leg of the LED is connected to a resistor, a 220k resistor. If you can see it here close by, there's a 220k resistor, and the other leg of the resistor is connected through a red wire to the negative the 0 volt pin, right, which is basically called a negative pin, which is the physical pin 1 2 3 4 5 6, physical pin 6. So as soon as you plug in, the LED glows, so which indicates that there is a direct current coming into the LED from the GPIO. So this is proven, this is evident. Now what does it mean? We are just glowing an LED, right, through directly connecting to 3.3 volt and the negative rail. So negative rail of GPIO, or you can even directly take the LED and plug it into both the points with a resistor in. So it works. What's fun about that? Well, nothing much. But now let's try to blink this LED on and off, on and off. That means 0 and 1, 0 and 1. 0 means off, 1 means on, right? That's the way the logic works. In order to make that logic work, we need to write some codes, right? It's a program. So what is that program? We are going to write a MicroPython code, but we might want to change little bit of the circuitry. For example, say here right now, one of the pin is directly connected, the positive rail is connected to 3.3 volt, right? That is the yellow line you can see from the breadboard, connected to 3.3 volt, and the negative line is connected, negative line of the LED is connected through resistor and goes to the 0 volt pin of Raspberry Pi. But in order to make it programmable to glow 0 and 1, off and on and off, 1 and 0, right, we need to send a signal out. So how do we send the signal? The positive terminal has to move on to any one of the GPIO pins. So understand the GPIO pins, guys. So you pull up the chart and connect it to any of the GPIO pin, but whichever pin you are connecting, your program, your MicroPython code has to match with that pin number. So in my case, I am going to connect it to pin number 11. Probably I'll pick it up 11. Yeah. So I'm going to remove the positive rail here. Okay, see, the LED is off. I'm going to connect it to pin number 11. So 1 2 3 4 5 6 7 8 9 10 11. Okay. Yep, 11. So this is connected to 11, and let me double confirm again. 1 2 3 4 5 6 7 8 9 10 11. It is 11. Yeah. So the LED seems to be still glowing. Now we need to make it to blink. So let me go to my VNC. All right, I am taking remote access of my VNC window. There you go. So this is my MicroPython code. I am going to leave this code in my description, which is part of my GitHub. You can pick up this code. So I am defining the LED pin 11 here, and the GPIO is set to LED pin, GPIO out. So you can understand this code very well. Those of you are from Python background can easily understand. Those who do not understand, I can walk you through one-on-one. You can reach out to me. I can provide the explanation for line by line code, or you can take up my Python tutorial lessons as well. That's a parallel series which went on using Jets and Nano. So you might want to opt for that as well. So once we run this code, let's see what happens. Let me run this code. And my LED goes on and off. You can see in the serial print on the shell, it's printing on and off as well. Let me just make this window a little bigger. Can you see it? LED on, LED off, LED on, LED off. Okay, let me show you the circuit. You can check in the circuit as well. You can see it here. The LED is on, off, on, off, on, off. Fantastic. So this seems to be working perfect, isn't it? So as per the code, and if you look at the code on the terminal as well, it shows off, it prints LED on and off, on and off. Guys, so this is the way you are going to access your GPIO pin. So it's a pretty simple and easy project, right? But I want you to understand how the pins, the GPIO pins and all the 40 pins work, right? It's a simple LED project, but you can directly glow the LED. At the same time, you can send a signal to GPIO pin and activate it by 0 and 1 through MicroPython. Alright guys, so have fun with this project. I'm going to come back with more and more number of such projects till we get more advanced, and then over a period of time I'm going to cover computer vision aspects using the camera and start capturing some images, do some AI projects and stuff once we finish with electronics and stuff like that. I will see you soon. Goodbye.